Hello, fellow programmers. Welcome back to this Animator PLC course for our problem-solving exercise. And today we're going to solve the exercise with a robotic house and a smart house. So, step one, we're going to analyze the instructions. Instruction one says, get data for time through signal B semicolon 0 and the minutes through signal or B semicolon 1 memory. Let's analyze this. Well, actually, apparently these memories have been directed here as it says. So apparently our first instruction is already solved, but it's telling us what it does or what each memory does, which in this case, from 0 it's getting the hours and B1 gets minutes. So instruction number 2. When it's 5 p.m. or 1700, open gate O0.6 for 3 seconds using a timer. And it's indicating us our timer and the type of instruction, which is timer on delay. Okay, perfect. Now then it says power on living room lamps O 0.7 from 1800 hours to 2100 hours. Okay, so power on lights from 1700 to 2100 hours. Open curtains from 6 a.m. to 7 a.m. All right, so these are the lights. So open shades, close the shades, shut everything off. And finally, for manual mode, well, this is actually easier. But I'm going to solve this together with you guys all the way through to instruction number 6. And in instruction number 7, you guys are going to do this. But if you wish, I can leave you with an example and then you guys can continue on with this. So perfect. Now, basically what we need to add, or the trick here, the instruction to run these types of drills or exercises. Let's suppose that the best instruction, I think, that could help us solve this exercise more efficiently is through limit instruction. Now here, it's indicating us, basically, that we need to activate all outputs. So what do you guys say if we start adding lines? And we are directly going to direct it. And we're going to direct those outputs. So we have O semicolon 0.0, 0.1, and so on until our output. All right, so we're going to direct this from 0 to my output number 7. Okay, so 5, 6, and 7. Perfect then. Now let's analyze how we're going to activate these. With our first instruction, we have nothing. Second one, when it's 7, open gate, which is number 6, for 3 seconds using a timer on delay. And then further down is where we're going to add our permissions, which in this case is going to um, indicating to make it a timer on delay. We select it. Perfect. 3 seconds. And here on this side, it's actually going to be a limit. And here on our limit, we need to remember that we have our bottom limit and we have our upper limit, our lower and upper limit. And we need to test our memory. So which one are we going to set? It's telling us that whatever it is, 5 p.m., it's going to open the gate for 3 seconds. Perfect. Now, it would actually be, instead of a limit, I think it's going to be, an equal or greater than. Actually, I think is, it's a GEQ, which is greater or equal to. So we're going to compare these. If the memory V0, which is time, is larger or as large as, or equal to, sorry, 17, so perfect, then it's going to power on this timer for 3 seconds. And if it's for 3 seconds, we're going to use our flag, .tt. So we're going to leave it here on the bottom side. So T0.tt. Very good. So it's going to turn 5 p.m. Timer is going to activate. And during that time for 3 seconds, this gate is going to activate. So first and second instruction, they're done. Third instruction, power on living room lights O semicolon 0.7 from 1800 to 2100. Okay. Sorry guys. Uh, I had to click pause for a bit. Okay. All right. So output number 7 between 6 and 9 p.m. should activate this output. So we're going to activate our limit. And as proof, we're going to use our time memory, our hour memory. Our minute memory doesn't really make or wouldn't really make much sense because it's asking us for hours. So maybe the designer here probably did so by thinking this. And here, between 1800 and 21 hours. Okay? So only in this schedule is this output going to power on. Instruction 3, done. Instruction 4. Power on the other lights from 1700 to 2100. What are the other lights? Well, all of them. What else? All right. So open the shades. And here it's indicating us, it's giving us all the rest of the instructions, but it's not indicating except for these shades. So let's make an exception only for these shades. Let's add this permission for our other outputs, except for O semicolon 0.2. Okay, so we're going to add limits here to all of them, except for this one, which would also take you to a limit, but at a different time. So I'm going to add it as is. Okay, so limit and limit. Perfect. So it's indicating us, it's telling us that we should power them on from between 1900 and 2100 hours. Okay, so I'm going to link this directly to our software. So 19 and 21. This is the good thing about this instruction in our PLC. Everything is preset. So this makes it a bit easier. So we have here our data, 1900, 2100, perfect. And apparently instruction number 4 is already set. So open shades from 6 till 7, shut down shades, shut everything off. Everything's going to be off according to my same limit. So we're going to be running this correctly with my limit between 6, which is when people are going to wake up. And in theory, according to this person, from 6 to 7. So we power on our shades and we shut them off at 6. And finally, instruction number 7 says, wait for manual mode, activate through manual mode, but that's going to be you guys. But I'm going to give you an idea on how to solve this, okay? All right, so let's simulate this. We're going to start it off, and everything's shut off for now. So everything starts as of 1600 hours. Then the first thing that's going to start off is the garage, which we said if it's greater than or equal to, if it's uh, greater than or equal to 5 p.m. for 5 seconds, and then it shuts off. And then it says as of 6 p.m. till 9 p.m., this output is going to be powered on, which is number 7. Okay, here we go. So from 6 till 9 p.m. But we have also a condition that as of 7 p.m. till 9 p.m., everything else is going to power on. Let's see if this complies. Very good. So everything powered on, except for the shades. If you wish to add a condition with the shades, you guys can go on ahead. Let's see here. Everything's going to be powered on. Also, light number 7. But remember that this was powered on 1 hour earlier. Okay, let's wait a bit. So let's locate the shades. So shades here are not opening. It's still shut off. Till 2100 hours. Okay. So we're still indicating that it should remain on as far as scheduling goes. Okay. So here it was until 2200 hours. So we went over a little bit, but we can play also with the minutes, or give it a little bit more permission or indicate more permissions. So let's wait a bit. And when it's close by, when it's gonna activate the shades. Let's pause this. So we waited all till morning for our simulator to wait to see if this is open, even though shades remained open. So the condition was compliant. Okay, so from 6 to 7. And with this, we're basically done with this drill. Now, if we currently wish to add a parallel to our exercise, we wouldn't be able to add it to our limit because it doesn't fit. So for the following days or weeks, we're going to add this and we're going to redesign our line so that this is wider and taller so that we can enter this limit in our parallel and we can have that double comparison. Now that's where we would be able to add our automatic and our manual. Now there's a different way to add this, but I'd like to leave this up to you for homework. You could actually use either a virtual memory, which doesn't affect the time, and this memory, for example, this limit, which is between 19 and 2100 hours, we already know that it's affecting to other, I think around 4 or 5 outputs, but that same limit. And this same limit, we can add it also on the bottom part to activate for this virtual output, or we could even add a physical output, but just not make it within this exercise. In this case, O semicolon 1.0. And when it is, I can only play around with parallels. Oh, I made a mistake here. I'm going to eliminate this limit. And here now we can add this output. So 1.0. And we can start playing around with what we can use. So here we can activate our automatic or manual mode. This could actually be sooner. So here we can say that if it's not being used, it's not complying. And this is an output where we can play around with our manual mode and automatic mode. So how are you guys going to do this? I'd like you to solve this, guys, similar to this because this is the easiest way. And maybe you can say, like, well, Rodrigo did it, so I'm going to hit next. But the goal here is that you guys also need to practice. So I think this would be a very good option if you guys try to uh, finish the exercise with manual mode and the way that it states here, that each push button activates the output. So with this, we're done with our drill. If you have any comments, any suggestions, obviously, our eyes are open, and you can leave them in our comment box. Lately, I've been getting a lot more emails. I'm very happy about this, and I'm also getting our messages to our WhatsApp number or comments from people who have taken the courses, our employees, improvements. We are all very receptive. Okay, the app is not done. We're continuing to developing this, and as time goes by, it's going to be even better, especially for those of you who are studying this and want to learn the PLC world with practice. So I'll see you guys in our next class. Big hug and thank you for your time. Hi again. This is future Rodrigo. I kind of got the impression that you guys could have gotten confused with the way that I explained the limit with the parallel. So, this software is Studio 5000 for Allen Bradley. I don't expect you to learn this immediately because it's a subspecialty actually for Allen Bradley. But if you notice, these are very similar and very easy things. Okay? If you already took our Allen Bradley course, it's going to be much easier. But if not, all you need to do is pay close attention to this. So we have a limit, an instruction that we already saw for our smart house. But what was I trying to get to? So we compare our limit, our lower limit compared to our upper limit, and we compare it to our test in our memory, which in this case is a virtual memory, which I created, which is double integer. This is a physical memory, which is Boolean. And what I was saying, what I was recommending is to add, in this case, add manual and automatic. This is going to be an output, an input, sorry. So we're going to send this to the top here. But I'm going to change this to normally open. And here what it's indicating is output 0. Now I'm going to create the memory here. I need to assign if it's physical or virtual. So all you need to do is direct it, but it's the same thing. So this is a Boolean memory. So we can simulate this, but logically, we're going to need some drills to visualize. But we can view this here, and here we're going to download to our PLC. Okay. Which is like we were downloading the information to our PLC in physical, but it's also a simulator. So let's wait for this to end. Okay, this is like a run. Perfect. Now, this is what I was saying. Left to right, same thing. But what I want to get to is, what I want you guys to see is, if we had an input indicating that it could be an automatic motion on the upper part, we have our first condition that our selector is automatic. Second condition, we should power on that output when it's between a certain time and certain time, which is between 7 and 9 p.m. or 19 and 2100 hours. Now, this is not moving as an exercise, it's a drill, but we're going to force it. So we're going to simulate 8 hours. Sorry, uh, 8 p.m. Sorry, so it's powering on our output 0 because it's between that range, in that memory. But what would happen if we change our selector to manual? So we assign a toggle bit. So I'm simulating here. And what's here on my top side, what's set at 8, is not going to listen to it because this is automatic. Okay? But on the bottom part, I'm telling it, or it's telling me, that with one button, in this case, I'm going to change it to this one. Okay, perfect. So I changed this to a normally open contact. So it's listening to my upper path, and we have our manual selector. And now what's missing to power on this output is to press our button or our push button, our green. Okay. Now I'm just running this drill. So Control T. This is to simulate this output, and I'm assigning a signal. And this is as if I had it powered on. And it's like it's already been shut off. So we're basically forcing our program to run the action and the activities that we tell it to do. Okay? Just so you guys get an idea. We don't have this yet in our software, what we were talking about. But in our following days, we're going to add new elements, which in this case is the limit, greater than, our GEQs, and other features. All right, guys. Now I really am leaving. I just didn't want to leave you guys hanging. I had to tell you this. Okay? Perfect, guys. So, big hug and thank you for your time. I'll see you in our next class.